Okay, so good morning, class, and welcome to the session. And let's get started now. Okay, guys, quickly join. Are you able to see the screen? Paint window? Okay, so let's get started. How many people have joined? 11. What about others? Normally, I see around 20 people joining, right? Class में सबने join किया? Join? Okay, ठीक है. Those who have joined remotely, guys, please confirm if I'm audible.
Yes, sir.
Okay, fair enough. Thank you. Few much, but I think we should be able to. In 3 to 4 hours. Okay, would be having a question something like y is equal to beta naught plus beta 1 x1 plus beta 2 x2 have a error term. And why error term? Because there can be multiple lines and I need to choose the best line. Or you can say the error would be occurring because not all the points can fall on the same line, right? Whichever line you choose, not all the lines can fall on the, sorry, not all the points can fall on the same line. So that is why we need this thing, okay? So first of all, let's draw the diagram. Consider our data is something like this. Our data is X and Y. Okay. So for time being, let's take a very simple example. Let me say my X is the weight of the car. My X is weight of the car and Y is my MPG, miles per gallon. How many miles vehicle will travel in a single unit of fuel? Or you can say kilometers per liter of fuel, whatever, right? So can I say that this Y will depend upon my X? MPG would be a function of my weight of the car. So there can be many other variables, but as of now, let's take the only one variable, and whatever we do with one variable can be. And I'm repeating, number of X variable can be one or many. It can be many. It can be 100, 200, 1,000, any number of variables. But your Y variable, which is your dependent variable, and which is also known as your one. You cannot predict more than one thing at a same time. Okay, and that is why your equations in linear regression, you have something like y is equal to beta naught plus beta 1 x1 type of thing. But equation would be something different. If you are building decision tree, then also you would be having y, but some different equation. तुम कोई भी model build करो, y would always be on the left hand side, and y is equal to something of x, and that is why we say y is a function of x and not x is a function of y. Okay. So consider you have some data points. You have some, let's say, 50 records over here. So just let me put some number. Let's say weight of the car was 1,000 kgs and miles per gallon was, let's say, some 15 units. Weight was this much kg and miles per gallon was, let's say, 12.5. Weight was this much and this was this much. Weight was 1,300. Weight was, let's say, 11.9, whatever. And similarly, you have few more entries. Okay, you have few more entries. So totally how many records I have? You can say 50 records, 60 records, 100 records, 1,000 records. How many records? Okay. Now, if so, basically, what do I have? I have my x and y. So this, let's say this is your point 1, this is your point 2, this is your point 3, this is your point 4, this is your point 5. Till that time, you have your point. You have 50 different points. So will people agree that if I know the x and y value of all the 50 points, then I can definitely plot it on the graph? X and y axis को तो plot कर ही सकते हैं. Mathematically possible, logically possible. So consider all these points which I'm drawing. So as of now, don't make any of your notes. I'll keep on making the points when whichever you have to note. At the end, you need to draw this diagram. So diagram को ध्यान से देखते चले जाओ, ठीक है? And someone, once I explain, someone else will come and explain over there. Okay. So consider these are your 50 different points. What are these points? These were the points which were given in your data. So all these 50 points can be considered as your original points. Or this was your given data. हमने plot कर लिया. Now I can draw any number of line. कोई भी line हम draw कर सकते हैं. None of the line can cover all the points. So it means I need to have a line where my error is least. Where my error is least. Okay. Now how to move towards that point? Probably where error is least, kind of thing. So consider any line. Consider any line. Let me say I am taking this line. I am taking this line. Let me remove few points so that I get a, you can draw. Let me take this point. Okay, and then you have many points over here also. So for a reference, let's call this as point A. What is this point A? Point A is the original point. Original point as in it is coming from this original data. This is the line and I am calling this as your regression line, line of regression. If point is there, then I would be having its coordinates also. Let's say x1, y1 are the coordinates. Tell me any doubt till this point. No doubt. Everyone understands what is x1, what is y1? X1, y1 are the given points. Given coordinates, I'll say given coordinates of point A. And point A is also your original data. I have taken any line. You could have taken any other line, but as of now, I have taken this line. Now, if point A, then what I will do is I will draw 190-degree line. before drawing 90-degree line, let me say, how many lines are possible if I draw a line from point A to x-axis? I can draw any line. All these lines will cut your x-axis, right? But if I say I'm drawing a line which is at 90 degree to the x-axis, then only one line would be possible. ये symbol सबको समझ में आ रहा है ना? This symbol is of 90 degree perpendicular. If I draw a line which is at 90 degree to the x-axis, then only one line would be possible. You cannot have more than one line. Now this line is cutting the regression line. Let me call that point as point B. Let me call that as point B. Okay, come back to this diagram. Over here, I have 50 records. I have 50 records. So can I find the mean of Y? क्या मैं mean निकाल सकता हूँ? Definitely I can, because I will add all these 50 numbers. I will add these 50 numbers and divide it by 50, so I can get a mean by. Now this red line, अब ध्यान से देखना, this red line, this value is nothing but your mean Y. And this red line is parallel to your x-axis. This red line is parallel to your x-axis. So on this red line, what will happen? Only the value of x will change, y value will not change, because it is parallel to x-axis. तुम इस line पे कितना भी travel करो, only x will change, y will not change. So this red line, again I am saying, it is your mean y. You have taken the intercept and you have drawn a parallel. What is point A? Point A is your original point. Coordinates are x1 and y1. What is this dotted black line? This dotted black line is a line perpendicular to x-axis. So only one line is possible. Now this dotted black line cuts your regression line at point B and cuts your mean line, let me say, at point C. Cuts this mean line at point C. Since this black line is parallel to your, sorry, this dotted black line is perpendicular to your x-axis, so it is parallel to your y-axis also. So on this line, from A to B, when you move, only the value of y will change, value of x will not change. Yes or no? Yes or no? Yes. So can I say the x coordinate of B would also be x1? जो A का x coordinate होगा वही B का x coordinate होगा, because this line is parallel to your y-axis, and when line is parallel to y-axis, only y will change, x will not change. But y coordinate would be different, so let me call the y coordinate over here as y2. Same logic would apply to your point C. The x coordinate will remain same, but the y coordinate will change. Let's call it as y3. Any doubt till this point? Please बताओ. यहाँ तक समझ में आ रहा है? अगर यहाँ तक आ गया तो आगे प्रॉब्लम नहीं आएगा. x1, y1, x2, y2. Take a minute and let me know. सोचो जरा, जो मैंने डायग्राम बनाया समझ में आ रहा है? Okay, now x1, what is y1? Y1 is the original value, and what is y2? Y2 is the predicted value. The value which falls on the regression line would always be your predicted value. Can you notice that there is a difference between your y1 and y2? y1 and y2 के बीच में difference आता हुआ दिख रहा है? So it means there is an error. There is a difference between y1 and y2. It means there is an error. And what is the error? Error is nothing but, हमेशा याद रखो, error is nothing but actual minus predicted. Error is actual minus predicted. What was the actual value? Actual value was y1. Predicted value is y2. So it means error is there. Itna diagram problem. Take 2 minutes, 3 minutes, draw it comfortably. Okay. So what is the error? Error is nothing but y1 minus y2. Error is always actual minus predicted. And keep one thing in mind, if someone is thinking, why don't we calculate error as x1 minus x2? Then that thought process is wrong. Why? Because we never predict the x. We always predict your y. Okay? So while finding the error, only y will come into the picture. Actual y, predicted y. We never predict x. And even if you are trying to predict x, there is no point. Why? Because the x1 coordinate of A and x1 coordinate of B are same. Okay, we never predict x, we always predict y. Okay, now comes the little part where you need to okay. Now, before we move forward, guys, the way I have calculated the error for point A, or the way I have done the prediction for point A, I can do the prediction for any other point. Let me say if this is point A1, I can do the similar logic. Even if the point is below, let's say this is a point, then also the same thing can be done. I can draw a line and I can project the line. Okay. So this point A was just an reference purpose. The whatever I have done with point A, same thing can be done with your point, any other point. So it means I can do the prediction for any point. And if I can do the prediction, obviously I can find the error. ठीक है, अब यहाँ पे आओ. So yesterday in ANOVA, you were seeing that we have taken the square. अब आज तुम्हें समझ में आएगा that why do we take a square. Let me say this is your actual and this is your predicted. Let me say actual number was 40, predicted was 43. Actual was 70, predicted was, let me say 68. Actual was 80. So what is the error over here? Error is nothing but actual minus predicted. So 40 minus 43 is minus 3. 70 minus 68 is 2. 80 minus 79 is 1. 75 minus 72 is 47 minus 50. So what is the total error if I add? Total error कितना आएगा? So add करो. So minus 3 minus 3 minus 6 कितना आ रहा है?
0 सर 0.
So ये कट जाएगा और ये कट जाएगा. Number इंटेलिजेंटली डाला है मैंने थोड़ा. So if you do the summation, if you do the sum, it comes out to be 0. But now this is where you need to keep thinking. But error is not 0. ठीक है? अगर वीडियो देखोगा तो मैं ऑलरेडी आइडिया हो गया होगा. But error is not 0. Write one line. Error is an error whether you have done prediction more than actual or less than actual. Error is an error whether you have done the prediction more than the actual or less than the actual. Error is an error whether you have done prediction more than the actual or less than the actual. इसको कुछ ऐसा समझो. Let's say you predict there are India's playing match and you predict 2 times. First time you say India will win, but India actually loses. And next time you say India will lose and India actually wins. So what does this mean? Your prediction has gone right. जीत को हार, हार को जीत कर दिया? No. Both the time your prediction has gone wrong. So for one of them you have done the over prediction, for another you have done the under prediction. It doesn't mean that there is no error. So what I can do is I can do the square of error. So when I do the square of error, this minus 3 would be written as 9, 2 would be written as 4, 1 as 1, 3 as 9, and minus 3 also as 9. Now take the summation. So 9 plus 4, 13, 13, 14, 23, 23 plus 9, 32. So what is this 32? This 32 is nothing but sum square of error, which would be known as my SSE. ये chart draw करके SSE तक जाओ. Very simple concept, but at the same time very, very important. Negative and positive errors are getting cancelled out, so that's why I'm taking a square. I'm taking a square. पता चलेगा मॉडुलस क्यों नहीं ले सकते. अभी वेट करो तो. मॉडुलस ही क्यों? सिर्फ स्क्वायर ही क्यों? पावर 4 क्यों नहीं? पावर 8 क्यों नहीं? पावर 6 क्यों नहीं? वेट करो. मुझे पता है तुम लोग ये क्वेश्चन कहीं से सुन के आ रहे हो. ठीक है. Negative and positive errors should not get cancelled out, so we are taking the square. इसको कोई ऐसा याद रखो, 2 wrongs don't make it right, ठीक है ना। आज के दिन अगर कोई बहुत जल्दी आ गया, इसका मतलब ये नहीं कल देर से आ सकता है। Done? Okay. So this is your square. Why I'm taking a square? As of now, remember, negative and positive error should not get cancelled out. So we are taking a square. Later on, you will understand the another or the main reason why we take a square. Okay. Now, for finding the SSE, guys, what are the two values did I use? I used my y1 value and the y2 value. y1 and y2 का use किया. While finding the SSE, was there any role of y3? क्या y3 का कोई भी role था? Answer is no. I did not use y3 in any of my calculation till now, but y3 also comes into the picture. So for finding SSE, what did I use? I use my actual and the predicted. Now similarly, I can use my predicted and the mean value. What is y3? Y3 can I say is nothing but your mean y. Okay, can I say this is your mean y? So for finding, let me say I have this column. I have my predicted and I have my mean. I have predicted and I have my mean. Now, what were my predicted values? My predicted values were 43, 68, 79, 72, and 50. Let me write it over here. 43, 68, 79, 72, 50. So these are my predicted values. Now, what is the mean value? Can someone find the mean for these 5 numbers quickly? Python में ही डाल के add करो. Add all of them and divide by 5 in the Jupyter notebook. How much? 62.4. Okay. Can someone else please confirm? 62.4. So mean comes out to be 62.4. I hope people are clear. ये number कैसे आ रहा है? So I have taken the mean of your actual, mean of actual. ये देख रहे हो यहाँ पे, go back to this diagram. This, since you already have the data, you already have the actual y, you can find the mean y. And that is why I have found the mean of your actual, not the mean of your predicted. So what I can do, mean, so 62.4. So this mean would be 62.4, 62.4, 62.4, 62.4, 62.4. Now remember yesterday's calculation, एक ऐसा रो निकाला था हम लोग ने ना, जहाँ पे mean से continuously separate कर रहे थे, right? Now what I will do, I will find the difference between predicted and the mean. So I can find the difference between predicted and the mean, correct? And then what I will do, I will take the square of predicted and mean. And why I'm taking the square? So that negative and positive values do not cancel out. Is this thing getting clear? So I am taking the square of it. So the calculation part is almost similar to your SSE. Only thing is this time I am taking the mean value. You find the difference and then you take the square. Now whatever at the end you get, so you will get some numbers and then you find the mean of it. So what you will get, you at the end you will get a single number because you are taking a mean, and that would be known as your SSR, sum square regression. Sum square regression, SSR. इतना सबको समझ में आ रहा है? How did we got SSR? The logic is same. You have the predicted value, you have the mean value, predicted minus mean. You take the square of predicted to mean, and then you get your SSR, sum square regression. क्लियर है गाइस यहां तक? सम स्क्वायर रिग्रेशन. Now let's come back to this slide again. Since linear regression, you want to draw something? Okay, let me know once you've done it. I'll just wait. Okay. Now, linear regression is a predictive model, right? Linear regression is a predictive modeling. It is a supervised modeling. So whenever you are doing any predictive modeling, you always want to evaluate your model. You always want to evaluate the model. What does this mean? Evaluate the model. Check the model for what? You always need to evaluate the model. क्यों evaluate करना होता है? To get the least error, okay. You are using a predictive model. You need to evaluate the model. It means you need to find the performance of the model, which means how good or bad your model is. Because उसी के basis पे you are going to do the prediction. So you need to be, you want to know that how accurate my model is or how much error my model is giving, right? Otherwise उस model को use करके क्या फायदा है जिसके बारे में खुद नहीं पता वो कितना accurate, खुद सोचो, right? You need to evaluate the model. You need to check the performance of the model, how good or bad the model is. That is one thing. And another thing is, remember in linear regression, I have said that there are multiple points. So you can draw any other line. You can draw many lines, but I need to select the line where my error is least. That is one thing. And since it's a predictive model, you obviously want to check the performance of the model, how accurate my model is. दुनिया का कोई भी मॉडल 100% एक्यूरेट नहीं होगा. If it is 100% accurate, then what does that mean? It's wrong. It means you have made some mistake. तुमने कुछ गलती कर दी है. That is why it is 100%. Okay. Now evaluate the model. So for model evaluation, what I will do is I will use a matrix known as my R square. Some people also represent R square as this thing. That is also okay. But normally I take it as R square. R square, the formula for R square is SSR upon SST. SSR you already know. हमने अभी निकाला है. SST is sum squared total. This T stands for your total. Now SSR upon SST. SST is nothing but SSE plus SSR. SSE plus SSR. R square is nothing but SSR upon SST. What is SST? SST is nothing but SSE plus SSR. Now, this is the formula of R square. Let me again write it. So R square formula, I am marking it to be remembered. Highly important formula. जिसको याद रखना है. ठीक है? Try remembering it. Now R square is SSR upon SSR, or you can say SSE plus SSR. Now, SSR. What is SSR? SSR is sum square regression. It is sum of the squares, so it means it would always be greater than or equal to 0 because squares can never be negative. So SSR would be greater than or equal to 0. So if there is no difference between actual and predicted or predicted and the mean, then SSR can be 0. Can I say the same logic will hold true for your SSE also? SSE is nothing but sum of the squares, and squares are negative, so it would always be greater than or equal to 0. Correct? Now, again, let me write the formula. So SSR upon SSR plus SSE. So can I say SSR is a positive number? And SSR plus SSE is also a positive number. If you divide two positive number, answer again has to be positive. Barabar? So what does this mean? This means R square would always be positive. R square kabhi negative nahi ho sakta, because numerator and denominator both are positive. And why they are positive? Because they are sum of squares, and square can never be negative. Okay, now will people agree that SSR plus SSE would be greater than or equal to your SSR? Yes, why? Because SSE is also a positive number. Am I right? SSR plus SSE would always be greater than or equal to SSR. So what does this mean? This means denominator is normally more than the numerator. अगर denominator numerator से ज़्यादा है, it means this answer, this value can never be more than 1. This value can never be more than 1. And we are saying that this value can never be less than 0 also. This value can never be negative also. So what does this mean? This implies that your R square range would be 0 to 1. Please remember this statement. दुनिया हिल जाएगी लेकिन ये वैल्यू कभी चेंज नहीं करेगी. R square has to be between 0 to 1. Okay, range of R square would be between 0 to 1, including 0 and 1. 0 तो शायद कभी जाए 0. Okay, now I am saying that R square formula is SSR upon SSR or SSE plus SSR, whatever you say. This value has to be between your 0 to 1. 0 to 1, it cannot be less than 0, it cannot be more than 1. Now, in which scenario R square will move towards 1? R square 1 कब होगा? SSC की वैल्यू अगर 0 हो जाए, so if SSC becomes 0, if SSC, let me say, is moving towards 0, then this formula would be SSR upon 0 plus SSR, which would be close to 1. If SSC is moving towards 0, R square will move towards 1. Everyone agrees to this point? But now the question is, what is SSE? SSC is nothing but difference between your actual and predicted. And SSC will move towards 0 only when actual and predicted are same. And if actual and predicted, so SSC will move towards 0 if the difference between actual and predicted will keep on reducing. SSC will move towards zero when actual and predicted, the difference between actual and predicted keeps on reducing. And if the difference between actual and predicted is reducing, it means my model is getting better and better. Am I right? Model is getting better and better. So what I can do, I can choose a model which has the highest R square. अब वाला problem solve होते हुए दिख रहा है that you have multiple lines, which line to choose? You can choose a line where R square is highest. ठीक है? इसको note down कर लो with formula. R square is equal to SSR upon SSE plus SSR. So R square will move towards zero. Sorry, R square will move towards 1 when SSC will move towards 0. And higher the R square, better is the model. Note that line also. If you want to evaluate the linear regression using some matrix, R square is one of them. So higher the R square, better is the model. Higher the R square, better is the model. स्क्रीन नहीं दिख रहा है? ओके, लेट मी डू वन थिंग. मैं इसको थोड़ा सा छोटा करता हूँ ताकि सारी चीजें एक पेज पे आ जाएंगी. यू कैन हैव अ बर्ड आई व्यू. Okay. Now, so this is your R square. So R square will move towards 0. R square will move towards 0 when SSC, sorry, my mistake. R square will move towards 1 when SSC is moving towards 0. It may never be actually 0, but let's say it's slowly moving towards 0. Your model is getting better and better. Okay. Now, and then I'm saying higher the R square, better is the model. So in which scenario will R square move towards 0? R square 0 की तरफ कब जाएगा? Just check in this formula. See, R square will move towards 0 when SSC is moving towards infinity. जब SSC बहुत ज्यादा होगा, then if let's say if SSC is moving towards infinity, can we call this formula same SSR upon SSR plus infinity? If you add anything to infinity, then also answer is infinity. If you subtract anything from infinity, then also infinity. Now SSR upon infinity. If you divide anything by infinity, answer is 0. Infinity over here means a very large number. A very large number. So when errors are huge and SSC will move towards infinity only when there is a big difference between actual and the predicted values. If there is a big difference between actual and predicted. अब suppose करो, let's say actual value is 500 and predicted value is 4000. Then what is the error? Error is 3500. And for finding the SSC, you will take the square of this thing. So जब 3500 का square लोगे तो और बड़ा number नहीं हो जाएगा. Are you getting my point? So when SSC is moving towards infinity, it means errors are large. And if errors are large, तो इसका मतलब model है बेकार. Right? So it means when R square is moving towards 0, the model is getting worsened. Okay? And that is why we say higher the R square, better is the model. So if you have to select two models based upon the R square, then choose the model which has highest R square. Done till this point? No. R square. The technical name of R square is coefficient of determinant. Coefficient की spelling क्या बता कोई? COEEF. कोई एक जन बताओ प्लीज यार. CIENT. Coefficient of determinant. It is known as your coefficient of determinant. ठीक है. Technical name R square का ये है. It is known as your coefficient of determinant. Okay. Now, what does R square represents? In real terms. So I know the formula. The formula of R square is SSR upon SSR plus SSC, or you can say SSC plus SSR. It's one and the same. Okay. We also know that this value would be between 0 to 1. It cannot be more than 1. It cannot be less than 0. We also know that higher the R square, better is the model. But what does this R square signifies in the real world? इसका असली meaning क्या है? If I say R square is equal to 0.8, let's say you build the model and R square comes out to be 0.8, then what does this 0.8 signifies? What does this signifies? ये क्या signify करता है? बताओ तुम लोग तो देख क्या है? वो सारी चीजें तो मैंने पहले ही बोल दी. वो भी पहले ही बोल दिया. So normally ये चीज में कोई बताएगा इतना नहीं है, because शायद पता नहीं होगा या जो भी है. सपोज करो 0.8 आ गया या 0.82 आ गया या 0.27 आ गया या कोई भी नंबर आ गया, तो उस नंबर का मतलब क्या है? How much model is efficient? You are saying accuracy? No. कल की क्लास से कोरिलेट कर सकते हो? वेरिएंस निकाला था.
I think कि जो डाटा है वो रिग्रेशन लाइन से कितना मतलब वेरिएंस है, ये आई थिंक पता चलेगा उससे।
डेटा लाइन से कितना वेरिएशन? अच्छा ठीक है। पॉजिटिव कोरिलेशन नहीं. So X and Y may not have always positive correlation, they have negative correlation also. अच्छा देखो, before I write one statement what is R square, खुद अपने दिमाग से सोचो कि actually life में चलता कैसा है. Suppose करो, let me say you want to predict the MPG, miles per gallon of a car. Okay, ठीक है. So as of now, what variable I have taken? I have taken only one variable, that is your weight. But I can take some another variables also. So let's say this x1 was your weight. I can take x2 as your, let's say, how many gears the vehicle has. I can also say how many cylinder the engine has. I can also say which type of fuel the car is using, whether it is petrol driven, gasoline driven, whatever. I can add another factor also, that what is the traffic condition or what is the weather condition. Okay. And then there can be many other factors. And then you have your Y factor. Let's say there are two cars, car A and B. For car A and B, all the variables are same. The weight is also same, gear, cylinder, fuel, traffic, weather. Everything is same. So what do you think? Their Y would be exactly same? क्या exactly same होगा? Yes. किसने बोला yes? इस क्लास में मैं सबको एक साथ पढ़ा रहा हूं, तो क्या सबको एक साथ समझ में आ रहा है? बताओ. So my teaching is X, your understanding is Y. So is the Y same for everyone?
No,
क्यों
sir.
different है? क्यों difference है? Can you quantify that difference? Can you put that difference? Why that difference is coming on basis of number? उसको numbers में represent कर सकते हो क्या? So suppose you travel in a car or bike or whatever, तब तो car भी same है, and the person who is driving is also same. Do you think, and probably the distance is also same, road is also same, and the, let's say, the traffic conditions are almost same. Do you think it will take the totally exact amount of fuel? अगर कल 1.1 लीटर लगा था तो आज भी 1.1 ही लगेगा? Is it possible? जरा सा भी डिफरेंस नहीं आएगा? आएगा. बट क्यों आएगा? All the X are same. क्यों आएगा? Because Y is a function of X. Person is same ना? You are only driving ना? But why? Person is same ना? Driving क्यों differ होगी? Person तो same है. Let's say is driving at the same speed. सारे पैरामीटर सेम है. What do you think? The Y would be exactly same. Suppose करो. Let me take one more example. Let's say there are twins, identical twins, either both boys or both girls. So their age is same. Let's say उनके age का difference it was just 1 minute. ठीक है? So their age is same. Their parents are same. They go to the same school. They eat the same food. Everything, they go to the same school, same teacher is teaching. They play for the same time. Everything is same. Then what do you think they will get the same marks? एक एग्जाम होता है तो क्या हर बार उनको सेम मार्क्स ही आएंगे? नहीं. But why? Why won't they get the same marks? All the X are same. IQ can be different. Can you quantify that IQ? Can you label that IQ on basis of a number? कि उनके बीच के IQ में difference क्या है? Can you, so probably there is some difference in their brain. एक का grasping power ज्यादा है, क्या कहता मैं? बट क्या तुम उसको नंबर्स में रिप्रेजेंट कर पाओगे? कैन यू find that difference and put it as one of the x variable? Probably answer is no. ना समझ में आ रहा है? So what does this means? This means, so what I have done, I have taken many x variable x1, x2, and I have taken, let's say, some 50 x variables I have taken, or 500 x variable. कितनी देर सोते हैं, क्या खाते हैं, पीते हैं, everything is same. उनके numbers जरूरी नहीं कि हर बार same आए. Then what is leading to that difference? कोई तो ऐसी चीज है ना जो डिफरेंस ला रही है, क्या हो सकती है? Answer is I don't know. There is something which is bringing that difference, and probably that is known as your bit of randomness. बादल कभी आते हैं, पानी बरसता है, कभी नहीं बरसता. ठीक है? And so basically what I want to convey over here is, when you keep on adding the x variable, your model may get better, but no matter how many x variable you add, you cannot explain the complete variance. What is variance? Variance is difference in your actual variance is nothing but difference from your mean. Variance is nothing but a kind of randomness. No matter how many variables you take, you cannot explain the 100% randomness. So now come to this thing. Is this idea getting clear? So let's say if my r square is 0.8, this implies that your x variables are able to explain 80% of the variance of your y variable, which also means that 20% of the variance, your model is not able to explain. ये होगा. Your x variable are able to explain 80% of the variance, and 20% of the variance it is still not able to explain. And variance over here represents a kind of randomness. तुम कितने भी x variable डाल दो, कितना भी कुछ कर लो, 100% variance or randomness you cannot explain. There would still be some unknown factors. Some unknown factors are then which you cannot consider them as part of your x. Clear? Is this point getting clear? No matter what you do, you cannot explain the 100% variance. Okay. And whatever examples I have taken, these are not hypothetical examples, these are real examples. तुम अपनी लाइफ में कुछ भी उठा के देखो, क्या तुम 100% एक्सप्लेनेशन दे पाओगे किसी चीज का? कभी नहीं दे पाओगे. अब इसी बैच में कुछ की पहले जॉब लगेगी, कुछ की बाद में. क्या तुम इसे एक्सप्लेन कर सकते हो? पढ़ाने वाला तो सेम है. ठीक है. Now, so r square. Let's again talk about r square, whatever we have discussed. Let's talk about the formula. Formula is SSR upon SSR plus SSE. The range of this would be from 0 to 1. Higher the r square, better is the model. Another name for r square is coefficient of determinant. Coefficient of determinant means it is able to explain that much percent of variance out of those x variables are able to explain that much variance. Okay, and I have already shown you the diagram. Now comes the another very tricky thing. So I am saying higher the R square, better is the model. Okay, higher the R square, better is the model. But now comes the problem associated with R square. Problem associated with R square. Problem associated with the R square, or you can say what is the drawback of R square. Now the drawback of R square is, let me write it like this. R square keeps on increasing. Even when the x variable is not significant. ये लाइन याद रखो, इट्स अ वेरी 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 इंपॉर्टेंट लाइन. जिसके माइंड में आया इग्नोर कर सकते हैं, वो आइडिया चेंज करो. R square keeps on increasing even when the x variable is not significant or it is not important. We consider that higher the R square, better is the model. But at the same time, you keep on adding insignificant variable and R square keeps on increasing. ये प्रॉब्लम है. ठीक है, I know people don't understand much about these two lines. Don't worry, I'll explain them. As of now, just make a note of it. ठीक है, now let's come over here. See guys, let me say you are trying to predict the mileage. You are trying to predict the mileage of the car. So this will become your y variable. So mileage of the car can depend upon many variables. It can depend upon the weight of car. It may depend upon your cylinder. It may depend upon your fuel type. It may depend upon your traffic condition. It may depend upon your, let's say, weather. Right? So consider one thing. Let's say you are building. अब ध्यान से सुनना सब लोग. Let's say you are building the model. You build the first model, model 1. While building the model 1, you have considered only the weight of the car. And consider your R square was 0.6. तुमने सिर्फ weight of the car consider किया. But mileage of the car may not only depend upon the weight of the car, it can depend upon other parameters also. So next time when you build the model 2, you are considering weight of the car also and plus your how many cylinder the engine has. So if the number of cylinders are very high, then the mileage is likely to go down. So it means cylinder was an important factor, but you did not consider while building the first model. So in second model you are considering, it means your R square this time, I don't know it how much it would be, but let's say it would be more than 0.6. थोड़ा तो बढ़ जाएगा because you are able to do better prediction. Then let's say when you build the third model, then you say that now while doing the prediction, I will consider the weight of the car also, cylinder also, and I will consider the fuel type also. So whether the car is moving on petrol, diesel, or LPG or CNG, whatever. So again, can I say that this value again will increase with this value? So let's say in your model 2, if the value was 0.62, over here this value would be more than 0.62. अगर यहाँ पे 0.62 आई थी, then it would be more than 0.62 because you are able to give more explanation. Similarly, based upon your traffic condition, your weather condition, whatever. So do you notice when I am adding the X variables, or can I say when I am adding the significant X variable? Significant X variable in layman terms means which are meaningful. Meaningful as in they have some relationship with your Y. They have some relationship with your Y. So when you are adding the significant variables, the R square will increase, and it makes sense also, it should increase. But suppose you add another variable, let's say color of the car. Whether the car is of red color, yellow color, pink color, जो भी color. Do you think that my MPG of a car will depend upon the color of the car? Depend करेगा? Answer is no. Color कोई भी हो, it will not impact the mileage. Will the mileage of the car depend upon the number plate of the car? कि वो PCMC में registered है या PMC में registered है, क्या उस पर depend करेगा? Answer is again no. Will the mileage of the car depend upon the color of the interiors? कि कार के इंटीरियर का कलर क्या उस पर डिपेंड करेगा? Will the mileage of the car, will it depend upon the engine number? जो इंजन होता है उस पर एक नंबर प्रिंटेड होता है, क्या उस पर डिपेंड करेगा? Answer is again no. Right. So can I say all these, though they are the X variables, but can I say these are insignificant variables? ये insignificant variables हैं. But if I want, I can use it while building my model. Tell me any question? क्या? You didn't hear what I said. कहाँ से hear नहीं हुआ? So all these variables, so color of the car, number plate, color of the interior, let's say engine number, all these can be your X variables. But all these X variables are the insignificant variables. It means they do not impact your Y. They do not have any relation whether it's positive or negative. They do not have any relation whether it's positive or negative with your Y. But as a person, if I want, I can add them also. So if now let me say my model was, I had built a model using my weight plus cylinder plus fuel type plus traffic condition plus weather conditions. This was one equation. Let's say equation A. Then I build another equation. I say Y is equal to weight plus cylinder plus fuel plus traffic plus weather plus, let me say, color of the car. In this model A, let me say my R square was 0.7. So what do you think in model B my R square would be? It would definitely not be less than 0.7 because I am using all the significant variables which I have used in A, but I am using some insignificant variable also. So 0.7 से तो कम नहीं होगा. It may slightly increase. It will slightly increase. So let's say it is 0.701, let me say. Now, because you are adding the color of the car, even it is not significant, but value of R square will not come down because you are using all the significant variables which you have used in A. Now, similarly, I can add the number plate. What is your number plate? Then I can keep on adding your color of the interiors, plus engine number, plus chassis number, whatever. Do you notice that number of insignificant parameters can be many? Number of insignificant parameters can be infinite in a way. Okay. But if you keep on adding the insignificant parameters also, the R square will never going to decrease. कभी कम तो नहीं होने वाला. Till the time you reduce the significant parameters, R square will never decrease. But does it make any sense to include these parameters? Does it make any sense? क्या कोई मतलब है इनको include करने का? No. But it doesn't make any sense. But if you are adding these insignificant parameters, the model, the R square will keep on increasing, even though if it increases slightly, but it will definitely increase. It will definitely increase. So अब एक चीज notice कर रहे हो? So if you keep on adding the insignificant parameters, R square is increasing, and I am saying higher the R square, better is the model. So don't you think that person is artificially increasing the R square? मॉडल उतना अच्छा नहीं जितना अच्छा दिखने लगेगा. तो कुछ प्रॉब्लम आती हुई दिख रही ना? ठीक है. So is the idea getting clear? That what is the problem with your R square? Problem with your R square is that it never decreases. So if you increase the parameters, if you increase the X variable, R square will always keep on increasing. It will never ever decrease. And there is no point adding all these insignificant parameters because they are artificially increasing your R square. सबको प्रॉब्लम समझ में आया? So that is why I was saying, please remember this line. It is very, very, very important. ये लाइन हमें बताता है कि R square का प्रॉब्लम क्या है. अगर प्रॉब्लम है तो कुछ सोल्यूशन भी आएगा. नाउ विल मूव टुवर्ड्स द सोल्यूशन. ठीक है ना? कैन वी मूव टुवर्ड्स द सोल्यूशन गाइस? So we already know the what is the problem of R square. Now solution to that R square is your adjusted R square. R square को adjust करो. अब करो जितनी बेमानी करनी है. Adjusted R square. Formula for adjusted R square, again very important. I recommended that people remember this formula. So formula for R square is 1 minus R square into n minus 1 upon n minus k minus 1. 1 minus R square into n minus 1 upon n minus k minus 1. Now the question is, what is n and what is k? N is number of records. Number of records, which means number of rows. Number of rows which were used in the data which was used for your model building. Number of records in your data. Normally trained data, because you would be building the model on that trained data. जिस model पे fit function run हुआ ना, उसके number of records आएंगे. And what is k? Can I have answer? Columns नहीं, number of x columns. उसमें y included नहीं है. Number of x variables you can say. Suppose my equation is like this: y is equal to beta naught plus beta 1 x1 plus beta 2 x2. So value of k would be 2 because I am using x1 and x2. तो यहाँ पे value of k हो जाएगी 2. एक equation के साथ उसके map कर लो. ठीक है, y is equal to beta naught plus beta 1 x1 plus beta 2 x2. So the value of k would be 2, not 3. K represents the number of x variables. And rest everything is, you already know what is R square. Consider. Now let's try putting some number. Let me say I build a model and my R square was 0.8. Number of records were, let me say, 100. And value of K was, let me say, 9. Okay. So K as 9, it means you are having 9 X variables. So let's put it back in the formula. So 1 minus R square. So 1 minus R square would be nothing but 0.2. And minus 1 would be how much? 100 minus 1 is 99. Then 100 minus 9 minus 1. So this would be written as 1 minus 0.2 into 99 divided by 100 minus 9 minus 1. This would be 90. This would be 90. So 1 minus, iski value please nikalo. 0.2 into 99 divided by 90. मुझे फाइनल वैल्यू नहीं बोलना, सिर्फ इसके अंदर की वैल्यू बोल रहा हूँ. 0.22, right? So 1 minus 0.22 is 0.78. So this is nothing but your adjusted R square. This is nothing but your adjusted R square. Can you notice that adjusted R square is less than R square? वो 0.8 था तो ये 0.78 हो गया. Please make a note of one statement. Adjusted R square can never be more than R square. Adjusted R square can never be more than R square. It can be equal to R square, but can never be more than R square. दुनिया हिल जाएगी अगर ऐसा होगा. Adjusted R square can never be more than your R square. It can never ever be. Adjusted R square can never be more than R square. Okay, now let's try to do one thing. Suppose, let me say the R square was 0.8, value of K was 9. And let's say a person comes and he adds some 6 insignificant variables. 6 insignificant variables as in color of the car, chassis number, number plate, license number, whatever. So if I'm adding 6 insignificant variable, the value of K will become 9 plus 6, that is a 15. Value of N will still remain the same, 100. Number of records are still same, number of rows are still same. But now let's say the R square increases. It will never decrease. So let's say R square increases and it moves towards, let's say, 0.81. Now again find the adjusted R square. Again find the adjusted R square where your R square value is changed to 0.81 and value of K has changed to 15. Value of N is still remains the same. So what will happen? I will put it over here. 1 minus R square. 1 minus R square would be nothing but 0.19. 0.19, right? Into N minus 1. N minus 1 will remain same upon N minus K minus 1. So 0.81. So 100 minus 15 minus 1. So 1 minus 0.19 into 99 upon this will become 16. So this will become 84. अब जरा निकालो adjusted R square की value. 0.77. दिखता है? So do you notice that when you are adding the insignificant variables, आर स्क्वायर तो इंक्रीज हो रहा है, बट एडजस्टेड आर स्क्वायर इज कमिंग डाउन. So now, if your person to whomever you are showing your model, अगर उसे आर स्क्वायर एंड एडजस्टेड आर स्क्वायर के बीच का डिफरेंस पता है, तो वो तुमसे जरूर बोलेगा कि भाई आर स्क्वायर तो ठीक है, बट मेरे को जो एडजस्टेड आर स्क्वायर दिखाओ. ठीक है. सो अगर तुमने आर स्क्वायर पर्पसफुली इंक्रीज किया आर्टिफिशियली, देन एडजस्टेड आर स्क्वायर वुड बी वेरी लेस, बिकॉज जैसे जैसे तुम के की वैल्यू बढ़ाओगे and r square is not increasing proportionally, adjusted r square will keep coming down. So keep one thing in mind, if there is a very big difference between r square and adjusted r square, it is an indication that some insignificant variables have been used. You need to get rid of them. You are using some insignificant variables. You need to get rid of them if there is a big difference. If there is a big difference between r square and adjusted r square, it is an indication that some insignificant x variables have been used. If there is a big difference between r square and adjusted r square, it's an indication that some insignificant variables have been used. Okay. Now, let's discuss about the range of adjusted r square. Let's discuss about the range of adjusted r square. Range of adjusted r square. Formula for adjusted r square is 1 upon 1 minus r square into n minus 1 n minus k minus 1. So the first statement is obvious that adjusted r square would always be less than or equal to r square. It can never be more than r square. Now, so what is the maximum value of adjusted r square? R square, adjusted r square की maximum value क्या हो सकती है? R square only, so it can be 1. Because the maximum value of r square is 1. So the maximum value of adjusted r square can also be 1. So for example, if your r square is equal to 1, if r square is equal to 1, then guys, this thing will become 0. ये 0 हो जाएगी. If this is 0, then this entire thing will become 0. And 1 minus 0 would be 1. So when r square is 1, then adjusted r square would also be 1. इसको note down करो. So it's very simple, but still make a note of it. If r square is 1, adjusted r square has also to be 1. Okay, so this was the upper range. What about the lower bound? What could be the lower range of adjusted r square? Lower limit क्या हो सकती है? Lower limit of adjusted r square. क्यों 0? अच्छा, let me talk about r square. So whatever may be the range of adjusted r square, जो भी कुछ होगा वो इसी फॉर्मूले से तो आएगा. इसी फॉर्मूले से रेंज आएगी. So can I say that r square, can r square be 0.001? Mathematically, it can be 0.001 because this number is still between 0 and 1. And take the value of n as 100 and take the value of k as, let's say, 9. अब जरा adjusted r square वापस निकालो. निकाल के बताओ जरा. सही निकालना। Why do you guys use mobile or anything? अपना लैपटॉप यूज करो ना। पाइथन से बढ़ के कौन सी चीज निकालेगी? Okay, let me do one thing. Let me put a formula over. Okay, so let me say r square is equal to 0.001. ठीक है? Value of n is 100. Value of k is 9. K is 9. What's the formula? Formula is 1 minus 1 minus then 1 minus r square, right? 1 minus r square. Let me say r square. 1 minus r square into n minus 1 divided by n minus k minus 1. R square क्या होगी? R square is, can you notice, minus 0.0899. आ रही minus में आ रही है? Or let me decrease this number even further. 0.0999. Let me decrease this number even further. ठीक है? So formula ठीक है? 1 minus r square into n minus 1 divided by n minus k minus 1. I think इसको ना ऐसे करना चाहिए. ये ब्रैकेट डाल देना चाहिए. ठीक है? Or if this is creating problem, let's do one thing. Let's find this separately. So this is 1 minus 0.0098. ठीक है? So what is the value I have taken? मैंने कितनी वैल्यू ली थी? 0.001. So when I take the value of r square, so the value comes out to be this value. Within the square bracket, the value comes out to be 1.0989. Now, since this value is more than 1, then this value has to be negative. तुम 1 में से एक बड़ा number subtract कर रहे हो, which is bigger than 1, then answer would be negative. So do you notice one thing, that when r square is moving towards 0, then adjusted r square is moving towards negative. And we already know that higher the r square, better the model. If r square is moving towards 0, it means model वैसे भी किसी काम का उसको पहले ही reject कर. So if adjusted r square is negative, then you don't even need to look at the model again. It means that model is of no use. Again, rebuild the model. Okay, because adjusted r square will move towards negative only when r square is moving towards 0. And we know that higher the r square, better the model. And value of r square towards 0, it means model is of no use. किसी काम का नहीं है. It would be having huge amount of errors. भर के errors होंगे उसमें. Now can adjusted r square be greater than 1? क्यों? क्योंकि मैंने बोल दिया कि r it cannot be more than r square. ऐसा भी तो सकता है मैंने गलत बोल दिया. That's what I am asking why. Acha, let's do one thing. Let me say r square is 0.7. ठीक है? And value of n is 40. And value of k is, let me say, 45. अब जरा निकालो. Find the adjusted r square. Adjusted r square की जब वैल्यू निकालो तो सही. ये तो ज्यादा है, कितना आ रहा है 1 minus 1 minus r square. So 1 minus r square would be 0.3, n minus 1 would be 39, n upon k minus n minus k minus 1. So 40 minus 45 minus 1, right? So 40 minus 45 minus 1. So can I say yeah, this is nothing but minus 6? Yes, this is nothing but minus 6. So 1 minus 0.3 into 39 upon minus 6. So ये number कितना आएगा? What is the 1.09? Can I say minus 1.09? So 1 minus minus 1.09. So this minus and minus will become plus. So answer हो जाएगा 2.09. तो बताओ क्या गलती हो गई? के एक्स वेरिएबल ज्यादा हुए हैं तो प्रॉब्लम है. So do you notice one thing? Based upon this formula, I have proved that value of adjusted R square is more than 1. But ऐसा हो नहीं सकता. तो कुछ गलती हो रही. क्या गलती कर रहे हो?
Records are less than 6 variables.
So this is happening. Why? Because k is greater than n. Do you notice? K n से ज्यादा हो गए. Now the question is, can k be more than n? क्या k कभी n से ज्यादा हो सकता है? Why? No. Why cannot k be more than n? सोचो. k n से ज्यादा क्यों नहीं हो सकता? इस क्वेश्चन का आंसर तुम सबको पता है, बचपन से पढ़ते आ रहे हो, क्लास 7th 8th से पढ़ते आ रहे हो. अच्छा एक चीज मेरे को बताओ. लेट मी से, अब तुम्हें लगेगा हाँ यार ये तो पता था. a plus b plus c is equal to 20, where a, b, c are real numbers. They can take negative, positive, any value. And let me say 3a plus 4b plus 7c is equal to 40. Can you find the value of a, b and c? निकालो. जिसने बोला है यस, मुझे a, b, c की वैल्यू निकाल के दिखाओ. हैं? We need another equation because there are 3 variables. So तुम कुछ भी कर लो, a, b, c की वैल्यू कभी नहीं निकलेगी. यूनिक वैल्यूज नहीं निकलेगी. If there are 3 variables, you need at least 3 equations. Now come to the same logic. What is k? K is nothing but your x variable. And what is n? N is number of record. Each record or each row is one equation. So if k is greater than n, it means you cannot solve the problem. It means model cannot be built. Model cannot be built. Model build हो ही नहीं सकता. तो जब मॉडल बिल्ड होगा ही नहीं तो आर स्क्वायर निकलेगा ही नहीं. ठीक है ना? So k can never be greater than n. Number of variables cannot be more than the number of equations. If you have 3 variables, then you need at least 3 equations. ठीक है? So this example which I have taken was a hypothetical example. ये real world में कभी exist नहीं करेगा. Real world में possible नहीं है. That you have more variables and less equation. Yeah. So what's the final conclusion? Final conclusion is that upper range of adjusted R square is 1 and lower limit, there is as such no lower limit. The lower value can be negative also. And higher the adjusted R-square, better is the model. Higher the adjusted R-square, better is the model. There is adjusted R-square cannot be more than 1. Done? अच्छा now. बस अब थ्योरी खत्म होने वाली है, 1-1.5 घंटा और. Let me say, give me some time. I'll put some numbers for you guys. Okay, so consider these were your actual and the predicted value. अब ध्यान देना please. Actual and predicted value. And what is error? Error is nothing but difference between your actual and the predicted. Actual and the predicted. So what I'll do, I'll put a simple formula. I'll say this minus this. Drop कर देंगे. I'll have it. Okay. Now, this is one thing. Okay, let me say the predicted values. Now, what's the error? Okay, let's take this thing. Let's say this is your model A. And this is your model B. Okay, this is model A, model B. You have to give me a answer to a very simple question. And the question is, out of these two models, do you notice the actual values are same? Actual values same दिखता है? Because I am building the model on the very same data, so actuals will not change. But obviously, I am building two different models, so predicted values are changing. And if the predicted values are changing, obviously error is going to change. You have to answer a very simple question. Which model do you think is better and why? कौन सा अच्छा है और क्यों अच्छा? कौन सा और क्यों? बस तुम्हें जब लीनियर रिग्रेशन बिल्ड करोगे यही एक पार्ट तुम्हें सोचना, आर स्क्वायर सोचना है, एडजस्टेड आर स्क्वायर और ये पैरामीटर्स, मॉडल एंड एवरीथिंग योर सॉफ्टवेयर विल बिल्ड. कौन सा और क्यों? और क्यों? Error is minimum. Okay. कौन सा और क्यों? आर स्क्वायर निकाल लिया तुमने, कैसे निकाला? तुमने निकाला आर स्क्वायर, तो फिर क्यों बोल रहे हो? या तो फिर निकालो. बी मॉडल अच्छा है, वाई? सम स्क्वायर बी मॉडल का कम आएगा, निकाला है या मन से बोल रहा है? निकाला है, कितना आ रहा है? ओके, सम स्क्वायर एरर बी का कम आ रहा है. आई डाउट. कोई जन ज्यादा बोल दो, कोई जन कम बोल दो, किसी एक का तो सही हो जाएगा. आधी क्लास ए बोल दो, आधी बी बोल दो. अच्छा, एक हिंट देता हूँ, इन दो मॉडल में से एक मॉडल सच में अच्छा है. दोनों बराबर, दोनों एक साथ अच्छे नहीं है. One of them is much better than the other one. One of them is much better than the other one. And now think which one? वो कौन सा है? ब्रेक नहीं चाहिए तुम लोग को? क्या चाहिए ना? तो फिर आंसर करो कुछ. जब तक थ्योरी चलेगी ब्रेक नहीं आएगा. मॉडल ए एंड वाई. इस बार तुम्हारा आंसर सही है. ओनली गिव द एक्सप्लेनेशन. हाँ हाँ, क्या बात है, इस बार तुम्हारा आंसर सही. आई रियली अप्रिशिएट. ठीक है, नाउ गाइस लेट्स हैव अ लुक. सो व्हाट इज द टोटल एरर? एक सेकंड प्लीज, पीछे बात नहीं करो. व्हाट इज द टोटल एरर इफ आई इग्नोर द साइन? लेट मी से इफ आई टेक द एब्सोल्यूट नंबर्स, एब्सोल्यूट एरर. If I take the absolute error, ABS का कोई फंक्शन होता है? हाँ है. If I take the absolute error, then let's see what's the total error. Let me say absolute error. वैसे मैंने कैलकुलेट करके नंबर डाले थे, but still I might have made some here and there. What is the absolute error? Absolute error is nothing but this. Okay. So if I take the sum of this column, what is the sum? 43. And if I take the sum of this column, this is also 43. Numbers calculate करके डाले थे. So do you notice that total amount of error is same in model A and model B? So if I focus only on these two columns, let me say this column and this column. Do you notice the total amount of error is same? The error is same, that is of 43, ignoring the sign. Then why is model A better? Model A is better when I take the square error. When I take square error. So when I take the square error, what will happen? I will say square chilta hai, square root chilta hai. I will say equal to this into this. Okay, I multiplied it 2 times. Now let me take the square error over here also. Equal to error into error. Now, let's take the mean of this thing. Let's take the mean. So I'll say equal to average. Average of square error. Average of square error. So let me say equal to AVERAGE. Average is this much. Can you notice that total amount of error is same in model A and model B? But then the mean value in model B is much higher than your value in A. देखो सबको समझ में आ रहा है? What is this 22.1? 22.1 is nothing but the average of column F, and 58.7 is nothing but average of column M. And what is column M? Column M is nothing but square of error. And same thing with your column F. So this is known as your MSE, mean square error. ठीक है? I think linear regression का most important matrix तो यही है. It is more important than R square adjusted R square. Mean square error. ठीक है? This is nothing but your mean square error. Mean square error is 22.1 in model A and it is 58.7 in model B. अब ऐसा हो क्यों रहा है? Can you notice in model B there are few numbers which are extremely large. For example, let me say 20. Can you notice that this number is very large and this number 13? If number is large, then square would be even larger. अगर number बड़ा है तो square और ज़्यादा बड़ा होगा. ठीक है? So keep. I hope people understand these type of things. For example, let me say 10 is just bigger than 9, but 10 square is much bigger than 9 square. ये 100 हो जाएगा और ये 71 है. Or let me say if 10 is just bigger than 9, that is fair enough. But 2 power 10 is much bigger than 2 power 9. इतना समझते हो? Right? So when you take the square, ठीक है? Now, again, why I am taking the square? Suppose, let me say your actual value is 300. If your actual value is 300, and if you do a prediction, we know that predicted value will have some errors. So let's say actual was 300, and if you predict somewhere between, let's say 280 to 330, I am still okay. Or if this range even still looks larger, let me say if I predict between 295 to 305, I am still okay. Right? But if the actual value is 300 and if you are predicting 200, then probably this type of model is of no use. ठीक है ना? This type of model is of no use. Or if actual value is 300 and you are predicting 450, then again this model is having large errors. Right? So basically, I know that my model would be making an error, but at the same time, I do not want large errors. I do not want large errors. I do not want large errors. अब वो क्वेश्चन क्लियर होता हुआ दिख रहा है? Why do we take square? अब उस क्वेश्चन का आंसर आने वाला है. So even when I take the absolute values, I am not able to differentiate between the model A and model B. Why? Because error are still same. But can you notice in model B there are few records? So let's say record number, this record, which I am marking in, let's say, green, this record and this record. Do you notice over here the errors? There are large errors. Error is of 20 unit and 13 unit. In model A, all the errors are between your range of 4 to 9. कोई बहुत बड़ी error आती हुई नहीं दिख रही है. So I am okay with small errors, but I am not okay with large errors. I don't want my model to make large errors. And that is why we take square. Why? Because if your errors are large, then square error would be even larger. Okay. Now make one note that why do we use MSC, or advantage of taking the square? There are two reasons why we take the square. One reason is very obvious, so that negative and positive errors do not cancel out. Negative and positive errors cancel out nahi ho jaye. That is one reason. Another reason is, or you can say another reason why we take MSC. In MSC we are taking the square of the errors and then we are taking the mean. MSC is used to punish or punish the model for large errors. MSC is used to punish the model for large errors. Now, lower the MSC, better is the model. Lower the MSC, better is the model. इतना याद रखना, higher the R square, better is the model. Higher the adjusted R square, better is the model. But over here it get reversed. Lower the MSC, better is the model. And what are the two main reasons why we look into MSC? Negative and positive errors should not cancel out, and it is used to punish the model for large errors. If errors would be more, MSC would be even more. अब बढ़ाओ तुम error. MSC बैठा है पता लगाने के लिए. ठीक है ना? Is this thing getting clear? Yes. Take 2 minutes and try drawing this Excel sheet, please. इस Excel sheet को create करो, please, everyone. Tell me. क्या doubt है? Guys, quickly talk about 5 minutes. बस 5 मिनट और, मुझे पता तुम सब लोग भूखे हो, बट भूख में पढ़ाई करोगे ना तो और अच्छे से पढ़ाई समझ में आएगी। ठीक है, लेट्स कम बैक ओवर। सो I hope people have drawn this sheet. Anyway, if needed, I'll share the sheet. This sheet I can share, not an issue. Now, let's quickly discuss about MSc. Or so, is everyone clear? What is this? 22.1. 22.1 is the mean of your error. So let me write this MSc little below. This is your MSc, and this is your MSc. Now, so let's quickly discuss about the MSc. Let me say what could be the range of MSc. Or let me ask a little different question. So consider, अब सब लोग ध्यान से क्वेश्चन सुना. Consider you build a model. You build a model and MSc is equal to 1. What would you say? Is the model good model or bad model? Eh? Lower the MSc, but अभी suppose करो you have built a model, and MSc is just 1. तो क्या लगता है? मॉडल अच्छा है, बुरा है, खराब है, क्या है? What is this? अच्छा तुमने ऐसा तो करा, ऐसे डायगोनली ऐसे कुछ अपने अपने हिसाब से भी नहीं थी मतलब बस सिंपल सा क्वेश्चन है, बट एट द सेम टाइम बहुत ही सिग्निफिकेंट क्वेश्चन है. You create a model, and let me say if this one is confusing, let me say you create a model and MSc comes out to be 2.7. Is this model a good model, bad model? दूसरे मॉडल से कंपेयर करेंगे. यस, दैट्स एब्सोल्युटली राइट आंसर. सपोज देयर इज एन एग्जाम, एक एग्जाम हुआ, एंड इन दैट एग्जाम यू गॉट 400 मार्क्स. सो व्हाट वुड यू से? द कैंडिडेट इज अ गुड कैंडिडेट. उसने अच्छा, उसकी परफॉर्मेंस अच्छी थी. I cannot say till the time I know these 400 marks were out of how many marks. If the total semester marks were 500, then it is still okay. But if the total semester marks were 1000, then the performance is different, right? So let me say if a candidate A got 400 marks, then I cannot say any conclusion. I cannot make any conclusion. But at the same time, if I have candidate B and he got 430 marks, now I can make a comparison. Even if I don't know the total marks, I can still compare that person B is better than person A. Now come to the same thing, MSc. What is the lower range of MSc? What is the lower range of MSc? बड़ा सिंपल सा क्वेश्चन है, तो बता दो. I am asking what is the lower range of MSc? Lower range of MSc क्या होगी? Lower bound. It cannot below. Yes, obviously 0. Why? Because you are taking a mean of the squares, and squares can never be negative. So if you take a mean of numbers which are positive, the lower bound is 0. Correct? So MSc can never be less than 0. Now what's the upper bound? Upper bound is infinity. Upper bound is infinity. In R square, adjusted R square, there was upper bound also. But in MSc, there is no upper bound. And that is why you cannot compare. You cannot make the conclusion till you have drawn two models. See guys, those who are still getting confused, ना मैं उनके लिए एक छोटा सा example draw करता हूँ. Let me say you are trying to predict the price of the house. And let's say the price of the house was 1, 10, 100,000, 10,000 lakh, 10 lakh, crore. So ये 1 crore हो गया. So this is 1 CR. You are trying to predict the price of the house. Let me say this was your actual value. and then you do the prediction. यहाँ से predicted word हटा देते हैं. You are trying to predict the price of the house, and then your model predicted the house to be, let's say, 99 lakhs. So what do you think? My model has done a good prediction? Just 1% error है. जो मकान 100 लाख का था उसको 99 lakhs predict किया, which is fair enough. But what is the error over here? Error over here is nothing but error is 1 lakh. Error is 1 lakh, but still I am saying the model is very good. Model ने बहुत अच्छा prediction किया. But consider another thing. So if you find the MSC would be what? 1000 का square करोगे and then you will take a mean. So it would again be 1 lakh only. But now let me say you are trying to predict the price of a mobile. And actual price of the mobile was, let me say, 50,000. And you have predicted it as, let's say, 40,000. So what is the error over here? Error over here is 10,000. But do you think model is doing good job? अभी अच्छा job नहीं कर रहा है. So if you find the MSC over here would be less. But still you are saying the model is a bad model. MSC over here is more, but the model is a good model. So do you notice that MSC depends upon the range and the magnitude of your target variable? If your target variable is in 10 digits, then MSC can be in 10 digits also. Are you getting my point? So just because that your MSC is 500 or 7,000, it doesn't mean that your model is a good model or a bad model. Because MSC depends upon the range and the magnitude of your target variable. If you are predicting the price of the house and the price of the houses are in several crores, then errors can be in crores also and can be in lakhs also. But if you are trying to predict the price of a mobile, which is in 5 digits, then error should be in 3 digit, 4 digit or 5 digits only. So now write one line. MSC cannot be used in isolation. MSC cannot be used in isolation. MSC can be used only when you have created 2 or more models. MSC can be used only when you have created 2 or more models. Lower the MSC, better is the model. MSC cannot be used in isolation. MSC अपने आप में वैसा है जैसे तुम रेस में अकेले दौड़ गए, हारे या जीते पता नहीं. ठीक है? So MSC cannot be used in isolation. Okay? MSC is used for comparison. It can be used only when you have created 2 or more models. Is this point getting clear? MSC. Now what about bus up? समझो बस 2 मिनट और. Just bear with me. Enjoy the theory, है ना? What is this ABS? If I take the mean of this column E, if I take the mean of this column E, ध्यान से देखना सब लोग. If I take the mean of this column E, then what is this 4.3? Is everyone clear? What is this 4.3? 4.3 is mean of your absolute error. So the technical name for this 4.3 is MAE, mean absolute error. Mean absolute error. Let's find the mean absolute error over here also. Can you notice the mean absolute error is same? And again, write the line, lower the MAE, better is the model. So we normally never evaluate the model based upon MAE because we already know the problem with MAE. We are only taking the absolute. So the problem of larger errors will still stay. बस 2 और मैट्रिक्स, RMSC and MAPE. Okay, now what is RMSC? RMSC is very similar to your this thing. What was MSE, guys? अब सब लोग एक जगह stop करो whatever they are doing. How do I find the MSC? Normally the mistake which people will do, वो ये वाली mistake कर देंगे. What people will do, they will find the error and then they will take the mean and then they will take the square. This has to be avoided. Approach जो लेनी है, error, then square and then mean. The tip is you always move from right to left. 1, 2, 3. अगर इस रास्ते से जाओगे तो कभी मिस्टेक नहीं होगी. Error निकाल लो, square निकालो, mean निकालो. Okay, error, square and mean. Don't go with your error, mean and square. So this is the wrong approach. This is the correct one. Okay. Now, what about RMSC? RMSC is nothing but your error, square, mean, and take the root. So if you take the square root of MSC, you get your RMSC. If you take the square root of MSC, you get your RMSC. MSC तो निकला ही हुआ है. So what would be my RMSC? My RMSC would be equal to SQRT of 22.1. This is nothing but your RMSC. And similarly, let's find the RMSC over here equal to SQRT. Square root of MSC gives you RMSC. समझ में आ रहा है सबको? This is nothing but your RMSC. Now let's quickly discuss about what would be the range of RMSC. Root mean square error. Root mean square error. RMSC is nothing but root mean square error. You take the under root. So what would be the range of RMSC? बड़ा simple है, फटाक से आंसर दे दो. 0 to infinity. Because MSC की range is from 0 to infinity. RMSC की range would also be from 0 to infinity. If you take the under root of infinity, that is also infinity. But मेरा question actually वो नहीं पूछना चाह रहा था, मैं पूछना चाह रहा था, when we are already finding the MSC, why do we even need to look into RMSC? अब RMSC ऐसा क्या ला रहा है अपने साथ कि हमें RMSC देखना चाहिए? अगर ये मैट्रिक्स डिजाइन किया गया तो कुछ सोच के डिजाइन किया होगा, क्या सोचा होगा? तुम्हारा ब्रेक तुम लोग के हाथ में है, मेरे हाथ में नहीं. सोचो. What is the inherent difference between RMSC and MSC? दोनों की रेंज सेम है. And I hope people understand one thing, that lower the RMSC, better is the model. Because RMSC is nothing but collection of error, like you're saying, your MSC. अच्छा. Mean absolute error also, lower the MAE, better is the model. See guys, it's very simple thing. मैंने ऐसी चीजें पहले भी एक बार बताई हैं. Let me say your actual and predicted. Let's say actual value was in rupees. Then predicted would also be in rupees. Then will people agree that error would also be in rupees? If you take the square error, then what would be the unit of square error? It would be rupee square. It means when you find the MSC, let's say MSC was 50, it means it is 50 rupees square. याद आ रहा है? इतना समझ में आ रहा है सबको? But if you take RMSC, it would be 50 rupee square. थोड़ी देर के लिए 50 की जगह let me say 49 कर लेते हैं, so that taking the square root is very obvious. 49, let me say. Then what would be the RMSC? 7 rupees. So the unit of RMSC and MSC are different. RMSE gives you the answer in the same unit in which your actual values are there. MSC gives you the answer in the square unit. So sometimes interpreting MSC becomes problematic because numbers बड़े shoot up होके आ रहे होते हैं. RMSC gives you the answer in the same unit in which your actual values were there. इतना समझ में आया सबको? Please remember all these points. Concept wise, these are very important. और तुम किधर भी जाओ, कोई भी आर्टिकल पढ़ो, ये सब पॉइंट तुम्हें नहीं समझ में आएगा, ठीक है? So try making your notes. So MSC, the units of MSC and RMSC are highly different. Now, अब बस last parameter. Let's come to one more important parameter. That is my MAPE. MAPE is your mean absolute percentage error. Mean absolute percentage error. And how would you remember this formula? Again, go from your right to left. पहले error निकालो, percentage निकालो, absolute कर दो, फिर उसका mean ले लो. Mean absolute percentage error. Error, percentage, absolute and mean. Let's do one thing. Everyone, please have a look over here. So I'm copying these values. So let me say this was your actual and predicted value. Okay. So I have copied this value. I have copied these numbers. So this was my actual and predicted value. Just try focusing over here. Probably I'll share this sheet if people want. Now let me go back to this formula. Error, percentage. So first of all, let's find the error. What is error? Error is nothing but difference between your actual and predicted. So this minus this. I hope everyone is clear with this formula. Now comes what is the percentage error. Before I apply the formula in Excel, let me say your actual value was 70. Predicted value was, let me say 65. Then error would be how much? 70 minus 65 is 5. Then what would be the percentage error? Percentage error is nothing but error divided by actual into 100. यही तो होगी ना percentage error. अगर प्राइस 50 था और अब 60 हो गया तो परसेंटेज इंक्रीज कितना होगा? 60 minus 50 divided by 50 into 100. So actual was 70, predicted was 65, error is 5. So percentage error would be 5 upon actual into 100. Or the formula is error upon actual into 100. यही formula होगा. Now let's put the same formula over here. So let me say percentage error भाई कितना है? So percentage error would be equal to this divided by this, and let me say into 100. So percentage error over here is 2. What error is this? So in my MAPE, I have found the error. Now let's try to find the absolute value. To find the absolute value, let me say absolute percentage error. Absolute percentage error. So what I'll do, I'll say equal to ABS and put it. ये आ गया absolute percentage error. So these 3 points have been done. Now only thing is your mean. So mean के लिए तो what you will say equal to average of all these numbers. 1.73. So what is this 1.73? It is nothing but your MAPE, mean absolute percentage error. Is the calculation part clear? Now let's discuss two lines of theory for MAPE. See guys, अब एक बड़ा डिफरेंस आने वाला है between your MSc and MAPE. Now before I talk about the difference, ये difference तुम अपने mind में खुद ही clear कर लो. So in one of the example I have asked, let's say if a candidate A got 400 marks, then I cannot make any conclusion that whether his performance was good or bad till the time I know out of how many. But let's say instead of giving the marks, it is said that person A got 85% marks. Then I don't even need to look into out of how many. 85% is 85%. Now, when you get the answer in percentage, even if I don't create the second model, I can still take a decision. अगर मैंने दूसरा मॉडल नहीं भी क्रिएट किया है, so let's say you want to select a candidate based upon the percentage. You see one resume and you see that his marks are these many. You don't need to compare with anyone else. You can still go ahead and take the interview. So you notice one thing that MAPE, since in MAPE we are talking in percentage terms. Connection किया क्या? We are talking terms of percentage. So even when you have created just one model, you can still take the decision. Note down one line: lower the MAPE, better is the model. Lower the MAPE, better is the model. Lower the MAPE, better is the model. So it represents the percentage error in your model. It represents the percentage error in your model. So even if you have created just one model, you can still use MAPE. Now, what you can do is, if MAPE, normally we, ऐसा statement हम लोग बोलते हैं, though it's not a 100% right statement. If MAPE is 7%, then accuracy is 100 minus 7, that is your 93%. If MAPE is 10, accuracy is 90. ठीक है? So lower the MAPE, better is the model. इतना समझ में आ रहा है सबको? ठीक है. So I hope लोगों को क्लास में मजा आया होगा. अब you guys can have a big break. So take a break of 30 minutes. ठीक है? अच्छे से चाय नाश्ता करो. ठीक है? I don't mind. But जाते जाते मेरा क्वेश्चन सुनते जाओ. ठीक है? And over the cup of tea, just try thinking. Try thinking. Just one more minute and then you go for the break. MSc. So what are the two advantages of taking the square? Can I have the answer? So one is your positive and negative values should not cancel out. And what is the even better answer? अभी देख पढ़ो. Lower the MSc, better the model, तो ठीक है, but square लेने का advantage क्या होता है? It punishes the model for the large errors. Remember? Otherwise, I could have just taken the absolute value. अगर large errors का problem नहीं होता, then I could have just taken the absolute value. But I am taking the square so that I can identify the large errors. वो Excel sheet कहाँ गया? अच्छा मुझे लगा बंद कर दिया. Remember these number 20 and 13. If error is more, then square would be even more. So इतना याद रखना. What are the two main advantages of MSc or taking the square is positive and negative error should not cancel out, and it punishes your model for large errors. Large errors. Which, what does this line means? This line means I am fine with small errors, but I do not want large errors. I do not want large errors. Up, if I take this thing, आप सब लोग ध्यान से देखो यहाँ पे, और जाने से पहले, I'll not say जाने से पहले, but जाने के बाद इस क्वेश्चन को सोचने की कोशिश करो. Suppose If I take the square, then negative and positive errors get cancelled out, and I punish my model for the large errors. So will people agree that these two advantages, negative and positive errors का cancel होना and to punish the model for large errors, these two advantages would be there even if I take the power 4, or if I take the power 6 or power 8 or power 10 or power 12 or power 14 or power 16, कोई भी even power अगर हम लेंगे, then also that these same two advantages would be there. Then why do we take only square? सिर्फ square ही क्यों? Why not power 4, 6, 8, 10, 12, 16, etc. etc. तो वही तो चाहते हो ना तुम, that it should identify the large errors. So see, probably you are trying to justify me only. देखो, look over here. Suppose when I take the square, when I take the square of the error, it would be what? It would be this into this, right? So when I take the square, it would be something like this. Now if I take the power 4, if I take the power 4, it would be what? Let me say equal to, power का कोई formula होता है? हाँ, power equal to POWER, power, number and power. हाँ, so let's say number is this, comma 4. So 2 minus 2 power 4 is 16. So now over here, for this line, the mean is how much? Equal to AVERA. Over here, the mean is this much. हमें पता ही था इसका मीन कितना होगा. Over here, the mean is this much. Okay. So do you notice that power 4 is punishing your model even higher? और वही तो हमारा aim है, to punish the model for the large errors. So why not power 4 or why not power 6 or why not power 8? ठीक है. Keep thinking and take a tea break. ठीक है. Yeah. So it is 11:15. Let's meet at 11:45.
Tadi
Recording in progress. Okay, so let's slowly start. Assumptions in linear regression. Assumptions. So what do you mean by assumptions? Assumptions in linear regression. Assumption का इंग्लिश मीनिंग क्या होता है? Some rules. Okay. Rules को तुम assumptions बोलते हो? Prediction तो prediction है. To assume, हाँ. क्या assume करते हो? Imaginary situation. Okay. Ajay, what is the difference between assumption and compulsion? Or you can say mandatory. Assumptions have to be applied at every circumstance. Compulsion. Karthik. Okay. So assumptions and mandatory requirement. So before I come to the what exactly the assumptions are in linear regression, let's try to discuss ये assumption का मतलब क्या होता है. Assumption is you are assuming something. Please उस fan को धीरा करो. It's making a lot of noise. You assume something. You are assuming something which may be true may not be true. तुमने assume कर लिया, ठीक है, it's okay. Which may be true, which may not be true. Suppose करो, let's try understanding it in a little lighter manner. तुमने किसी को वोट दे दिया, क्या assume करके दिया कि इंसान अच्छा काम करेगा, अच्छा नेता होगा, बराबर? That was your assumption. After 5 years, you will come to know whether your assumption was right or wrong. Right? But at the time of voting, you assume that whatever you are doing, or to whomever you are giving, casting your vote, that person would be a good person. That person would be a good person. So assumption is, let's say you start from your home towards the institute. Did you make any assumption? Knowingly, unknowingly, consciously, subconsciously? कुछ तो assumption तुमने create किया. So let's say class was from 10 a.m. and probably you are starting at 9:45. Then your assumption was, even if you wrote that assumption, in your mind assumption was कोई traffic नहीं मिलेगा. Sunday का time है, morning है. Without any traffic, I will reach home. I will reach institute. But maybe कोई VIP movement हो गया, road हो गई block. So what will happen? Your assumption goes wrong. But still you are assuming. You are assuming knowingly or unknowingly. Okay? That is what the meaning of assumption is. So assumptions, when I say about assumptions in linear regression, we make several assumptions while building model. We make several assumptions while building our model, which may be true, which may not be true. Even if assumptions are not true, you can still create the model. Model फिर भी आ जाएगा. You can still create the model. Only thing is your model may have some errors, or your model may be biased. Models, there would be certain problem in your models, but you can still create the model. And you may get a good model also with certain problems. You must still get the model even when the assumptions are. What about the mandatory conditions or mandatory requirements? Mandatory as in compulsory. If these requirements are not fulfilled, then you cannot create the model. So don't get confused between your mandatory requirement and assumptions. So mandatory requirements सिर्फ दो ही हैं linear regression में. You all that your y should be numeric and continuous. Numeric and continuous. That is one requirement. Another is n should be more than k or greater than or equal to k. Agar k is less than or if k is more than n, then model cannot be created. So these are the two mandatory requirements for your linear regression, that your target variable should be numeric and continuous, and number of variables should be less than the number of your records. Less than or equal to. Agar equal to bhi hoga, then to you will get a very straight line. The straight line as in all the points would be on the same line. So numeric and continuous, and n should be greater than or equal to k. So this is the mandatory requirement or the compulsory condition. But now let's focus on the assumption. Abhi assumption part we have बहुत important. Later on you need to check the assumptions. Okay. So what are the 4 assumptions? I will write them down and then discuss one by one. Please make a note of your assumptions and try remembering them. So the first assumption is very obvious. There is a linear relationship there is a linear relationship between x and y. There is a linear relationship between your x and y. Error terms are normally distributed. Error terms are normally distributed and there is no pattern among them. Error terms are normally distributed and there is no pattern among them. Third assumption, minimum multi-collinearity among only the x variables. Minimum multi-collinearity among the x variables. Fourth assumption, homoscedasticity. Homoscedasticity. Homoscedasticity implies variance around the regression line. Variance around the regression line is same for all the predicted values. Variance around the regression line is same for all the predicted values. I know you don't understand these 4 lines, but still make a note of them. We'll discuss one by one. Homoscedasticity. Homoscedasticity के सामने जो मैंने लिखा है, that is the definition of homoscedasticity. Variance around the regression line is same for all the predicted values. Minimum multicollinearity among x variables. Error terms are normally distributed and there is no pattern among them. There is a linear relationship between my x and y. Let me know once you have written. And please remember these 4 assumptions. याद कर लो इन्हें. Done. Now let's start discussing them one by one. So what is my first assumption? My first assumption is there is a linear relationship. There is a linear relationship between my. So what does this mean? Let me say I have an equation y is equal to beta naught plus beta 1 x1. So I am saying there is a linear relationship. It means the power of x1. So over here, I am having the power as 1. And over here also the power as 1. So I'm saying it is linear. I'm not saying it is a square or cube or 1.5 or 1.2 or whatever. So it means if y is equal to 3 plus 7 x1, then it means when x1 will change by 1 unit, y will change by how many units? अरे क्यों 1 unit? हे भगवान, इतना लीनियर पढ़ने के बाद भी ये सिंपल से क्वेश्चन में तुम लोग अब तो चाय भी पिला दी थी. 7 यूनिट. हाँ देखो वो सही दे रहा है, वही चाय पी के आया है. सपोज करो y इज इक्वल टू 3 plus 7 x1. Let me say value of x1 is 0. Then what would be the value of y? 3. When value of x1 is 1, then what would be the value of y? 10. अगर ये 2 होगी तो कितना होगा? 17. अगर ये 3 होगी तो कितना होगा? अभी भी मतलब लोगों को समझ में नहीं आया. आंसर देर से आ रहे हैं. Now 31. Now अभी भी समझ में नहीं आया, आंसर तेज आ गया, जब समझ में आ जाएगा तो आंसर फट से आ जाएगा। अभी भी समझ में नहीं आया। अब 52. Do you notice difference is always 7, or you can say difference is always m? So difference is always m. Why? Because m is the slope. And slope का formula क्या होता है? y2 minus y1 upon x2 minus x1. What is y2 minus y1? y2 minus y1 is change in y. और इसको divide किससे किया है? x से. Change in x. So what is slope? Slope is nothing but change in y with respect to change in x. So whenever you will change your x by 1 unit, y will change by m unit. Over here m was 7, that is why your change is also 7. इतना समझता है सबको? And why the change is only m? Change is only m because power of x is 1. If power of x is not 1, then change would not be m. It would be more than m or less than m. Are you getting my point? Let me say if the power of x1 is square, then every 1 unit change will result in a very large change in y. ठीक है, तो वो 7 का स्क्वायर हो जाएगा. So 3 plus 49 होने लग जाएगा. ठीक है. So do you notice one thing? That what is m? M is the change in y with respect to change in x. ठीक है. So over here I am assuming that relationship is linear. Relationship is linear. So what will happen if relationship is not linear? ऐसा assumption हमने क्यों करा? और rather why do we make any assumption? कोई भी चीज तुम assume क्यों कर लेते हो? थोड़ी देर के लिए भूल जाओ linear regression. Think in real life. Why do you assume something? To decide. Yes, you assume something to decide. So let's say you are going to cast your vote. So indirectly your assumption is कि कोई नेता तो ठीक है. If your assumption is सारे नेता खराब हैं तो वोट डालने नहीं होगा. Am I right? If you are coming to this class, then your assumption is that you will learn something. अगर if your assumption is कि कोई फायदा नहीं क्लास में आने से, कुछ नया सीखने को नहीं आएगा, तो you will skip that class. Right? So why do you, let's say your class is at 10 AM और तुमने start किया 9:45, your assumption was कोई ट्रैफिक नहीं मिलेगा. तुम घर में चाय बनाना चाह रहे हो, तो चाय बनाते टाइम कभी एक्सीडेंट भी हो सकता है, गैस फट जाए, आग लग जाए. If you assume all those things, probably you will not make a tea. But you are assuming कि कोई problem नहीं होगा, so you go ahead and make a tea. So you make the assumption so that you can proceed or you can make any decision. Okay? Flight में जा रहे हो, you are assuming कि accident नहीं होगा, है ना? और chances of accident are very rare. If you assume accident जरूर होगा, probably you will not sit in flight. Okay? So now come back to this point. Why do we assume that it's a linear relationship? By assuming, so do you notice one thing? When I make some assumption, my life gets simpler and I am able to make some decisions. तो linear क्यों assume कर लेते हो? होने दो, कुछ भी होने दो. Linear होने से क्या फायदा होगा? predicted value बढ़ जाएगी, घट भी तो सकती है. Let's say power is less than 1. Power can be less than 1 also. Do you understand that thing? It can be 0.9. So, for example, let me say if this is your equation, y is equal to 4x, or let me say y is equal to 4 plus 3x square. So over here, it is not a linear equation, it is a power equation. Or it can be y is equal to 4 plus 3x power, let me say 0.5, then it is root of x, right? But both of these scenarios are non-linear. सोचो लीनियर का क्या फायदा हो सकता है? लीनियर का मतलब ही स्ट्रेट होता है, स्ट्रेट लाइन का क्या फायदा है, वही मेरा क्वेश्चन है। एटलीस्ट वो ट्राई कर रही है, बाकी लोग। कांस्टेंट रिलेशनशिप, कैन यू डिफाइन इट लिटिल मोर? तुम्हारा आंसर इस बार राइट डायरेक्शन में है। लीनियर ही क्यों? लीनियर के एडवांटेजेस क्यों, क्या है? अच्छा चलो, लेट मी टेक दिस अप नाउ। कंसिडर if it is not linear, then it means it would be a kind of curve. अगर लाइन नहीं है तो कोई कर्व ही होगा। That can be any curve, it can be like this, like this, like this, कोई भी कर्व, कुछ भी कर्व हो, लेकिन होगा तो कर्व, because straight line you are saying it is not a straight line. It is not a straight line, then it would be a curve. Now let's say this is a curve. You are saying this is the graph or the solution you are using for your prediction. Let's say. अब ये ऐसी चीज शायद पहले भी डिस्कस करी है। लेट मी से, डू यू नोटिस, याद आ रहा है? CDE. So do you notice that every point the slope keeps on changing? Between A to B it is moving down, तो slope negative होती हुई दिखती है। Between C and D this line is parallel to your x-axis, so slope between C and D the slope would be 0, and then again the slope keeps on increasing. So at every point the slope is changing, and if slope is changing then relationship between x and y is not fixed, it is not constant. So it means at different point the impact of x on y will keep on changing. और अगर ऐसा होगा तो क्या होगा? Decision making will become problematic, and that is why I assume it to be a linear relationship, so that I can apply this formula y is equal to mx plus c type formula. For every unit change in x, the impact on y is always m. M is nothing but your slope. इसलिए linear create करते हैं। तुम्हारा क्वेश्चन क्लियर हुआ? ठीक है। So can I say that this assumption is clear, that there is a linear relationship between x and y, which means I am assuming, so if I am saying y is equal to beta naught plus beta 1 x1 plus beta 2 x2 or whatever, so I am assuming power over here is also 1, power over here is also 1, power over here is also 1. ठीक है, सबका पावर हमने 1 assume कर लिया। लीनियर रिलेशनशिप है। इन रियल लाइफ इट मे नॉट बी लीनियर ऑलवेज। रियल लाइफ में लीनियर नहीं होती सारी चीजें, बट यू स्टिल अज्यूम। सपोज करो, अगर लेट मी से, इसका एक बड़ा सिंपल सा एग्जांपल देखो कि दैट इन रियल लाइफ थिंग्स विल नेवर बी 100% लीनियर, दे विल नेवर बी 100% लीनियर। सपोज करो, एक एग्जांपल लेते हैं, लेट मी से, थोड़ी देर के लिए मान लेते हैं कुछ स्टूडेंट कम्युनिटी है, अभी वर्किंग नहीं है, लेट्स, ठीक है, उसके पास एक बाइक है, माँ बाप के पैसे पे भी पेट्रोल डला रहा है, ठीक है, तो बाइक है, एंड देन ही इज राइडिंग, उसको राइडिंग का बहुत शौक है, ही इज राइडिंग एवरी डे 100 किलोमीटर्स, और उस टाइम फ्यूल के रेट थे लेट मी से 50 रुपीज, गवर्नमेंट ने थोड़ा दाम बढ़ा दिया, 60 हो गया। So will this person reduce the from 50 from, so how much is the increase? The increase over here is 10 upon 50 into 100, 20% का increase हुआ है। So do you know, what do you think? He will start riding only 80 kilometers? ऐसा तो नहीं होगा ना, but let's say government अभी भी नहीं मानती, he is still riding 100 kilometers, थोड़ा मैनेज किया उसने, गवर्नमेंट ने अब 70 कर दिया, फिर भी वो बोला अरे ठीक है कोई बात 70, बट गवर्नमेंट ने फिर थोड़ा सा और चेक किया, चलो अभी 80 कर देते हैं। नाउ दिस कैंडिडेट इज लिटिल वरीड, अब फ्यूल का बिल थोड़ा बढ़ रहा है, सो इंस्टेड ऑफ राइडिंग 100 को थोड़ा सा रिड्यूस कर देता है, चलो भाई हम 90 में काम चला, थोड़ा 10 किलोमीटर साइकिल से, ठीक है, नाउ गवर्नमेंट अगेन इंक्रीजेस एंड लेट्स से बिल्कुल 120 कर दिया, तो उसने क्या करा, बाइक को डिस्कार्ड, छोड़ो पैदल जाएंगे. So do you notice the relationship is not always linear, but I still assume it to be linear. ठीक है ना? So that I can make a decision. Okay. So for example, let me say if you are increasing the weight of the car, then MPG, if you are increasing the weight of the car, the MPG will not be linearly proportionate. ऐसा नहीं होगा कि तुमने 1% इसका weight increase किया तो 1% माइलेज कम हो जाएगा, ऐसा नहीं होगा. But let's say if you increase the weight much more, then you will start feeling the difference, right? But still I assume it to be linear. I assume it to be linear. Okay, now let's move to the next assumption. Let's talk about the third assumption, minimum multicollinearity among the X variable. Minimum multicollinearity among my X variable. See, now I'll make one more statement probably which will confuse you. I want high correlation. I want high correlation between X and Y. X and Y के बीच में high चाहिए. But at the same time, I want minimum multi-correlation among X. ठीक है? क्या ये दोनों स्टेटमेंट थोड़े से कॉन्ट्रडिक्टरी लग रहे हैं? I want minimum multi-collinearity among my X variable. I want high correlation between my X and Y. But I want minimum among my X. See guys, let me say you are trying to predict the miles per gallon. So miles per gallon which would have a strong relationship between the weight. It will have a strong correlation between, let's say, your engine CC, how powerful your engine is. But it will have a very small correlation between color of the car. Let's say color of the car was red, blue, and green. And you have marked red as 1, blue as 2, and green as, let's say, 3. And over here also these are numbers. Since MPG is in number, color of car is also in number, then I can find the correlation. But the correlation may be very less. It may be close to 0. Right? Correlation between MPG and weight of the car would be very high. See, if I say correlation between A and B is very less, it means if you change A, there won't be change in B. Because unke beech mein to relation hi nahi hai. Right? Over here I am saying there is a correlation between my Y and X. So for finding the correlation, I can have only 2 variables. I am taking Y variable and I am taking X1 variable. Then I am taking Y and X2. I am taking Y and X3. I want this to be very high. Either very high or very low. Low also, as in it can be negative also, na? So even when the correlation is negative, it is still considered to be a strong correlation, remember? Okay, when value of correlation is close to 0, then it means there is no correlation. So for example, between your MPG and weight, would the correlation be positive or negative? अरे negative. Weight बढ़ाओगे तो MPG कम होगा ना? When weight will increase, MPG will go down. So it's a negative correlation, but still the weight is a significant parameter. So don't think if correlation is negative, it is not a significant. Are you getting my point? Okay, so relationship between weight and MPG would be negative for sure, Because when you increase the weight, MPG will go down, but still weight is a significant parameter. So correlation is either very high or low, means either it is towards +1 or towards -1. ठीक है, both of them are significant. But if correlation is towards the 0, अगर 0 के पास है, then it means there is no correlation or very less correlation. ठीक है, ये आइडिया क्लियर हुआ सबको? अगर नेगेटिव में है इसका मतलब ऐसा नहीं कि वो खराब है. ठीक है, now let's come back to the same thing. So what I'm saying is I want a strong correlation between my x and y, but I want minimum correlation between among my x. इसको एक एग्जांपल के साथ समझो. सपोज करो, let me say production of factory. So production of factory I am taking as y. For time being, assume this production of factory is manufacturing your textile plant. Let's say Reliance का plant है. It is manufacturing your yarns. Yarns समझ में आता है लोगों को? Thread, जो cotton के जो threads होते हैं, later on those same threads are converted into the cloth. So the production of factory will depend. What could be the x variables? Can I say this production of factory will depend upon number of machines you are using, number of spindles you are using, कितने चरखे लगा रखे, इलेक्ट्रॉनिक चरखे or whatever. So number of machines. Can production also depend upon the amount of raw material being consumed? Raw material. Can it also depend upon your manpower? Assume that on every machine you need 3 people or 4 people, manpower. So x1, x2, x3 production is also a function of electricity. By checking your electricity bill, you can get to know that kitna electricity used हुआ, then how much production can be there. Am I right? Any other factor? Okay, let me say total labor hours. So normally the factories are running around the clock, 24 hours चलती रहती हैं. Only I think in Diwali they may shut down for just maintenance work. So total number of labor hours would be how many labors you have and how many hours each labor is working per month or per day. Total labor hours. So you have 1, 2, 3, 4, 5. Any other parameter which you think plays a role in the production. And let me say production of yarn is in tons. कितना टन मटेरियल उसने क्रिएट किया. मैकेनिकल वालों बताओ, बहुत सारे मैकेनिकल आ रहे हैं ना, क्या है? और कोई फैक्टर हो सकता है? मशीन, रॉ मटेरियल, मैन पावर, इलेक्ट्रिसिटी, लोकेशन ऑफ प्लांट. बट लोकेशन ऑफ प्लांट हर बार चेंज नहीं करने वाली ना. बट ट्रांसपोर्ट से तो बनने के बाद होगा ना, पहले तो होगा. अच्छा चलो, नो प्रॉब्लम. I have 5 factors. So can I say y is a function of all the 5 factors? Beta naught plus beta 1 x1 plus beta 2 x2, beta 3 x3, beta 4 x4 plus beta 5 x5. Okay. Just for our reference purpose, let's put some numbers over there. These numbers are just for representation. Okay, let me say these numbers. This is your final equation. Okay, this is your final equation. So y is equal to 7 plus 3x1 plus what. Now what is x1? X1 is mapped to your machine. X1 is mapped to your machine. X2 is mapped to your raw material. X3 to manpower. X4 to your electricity. X5 is your labor hours. So what does this mean? This means This means when your X1 will increase by 1 unit, your Y will increase by 3 unit. याद आ रहा है सबको? अभी अभी हमने फॉर्मूला देखा था y is equal to mx plus c. So what is the slope of x1? Slope of x1 is 3. So whenever you will increase x1, y will increase by 3 units. Yes, no, maybe. Yes. But what is x1? X1 is nothing but the number of machines. But if number of machines are increasing, then amount of raw material consumed would also increase. बिना raw material के machine चला के क्या फायदा? Correct? So will people agree that raw material consumption will depend upon your machines also? Or you can say vice versa also. If you have more raw material, probably you are borrowing more machine. ठीक है ना? Whatever you can say. ठीक है? So if raw material, if machines are increasing, then let's say you are increasing the supply of raw material so that you can generate more yarn. So let's say there is a strong correlation between your X1 and X2. जितना ज्यादा मटेरियल उतना ज्यादा तुमने मशीन लगाने की कोशिश करो. So when X1 is increasing, let me say X2 is also increasing. But when X2 will increase by 1 unit, what will happen to your Y? When X2 will increase by 1 unit, what will happen to your Y? Y will increase by 4 units. बराबर? Now let's talk about the X3. ये भाई X3 क्या है? X3 is manpower. So if you are increasing the machine, on each machine, the man, you have to employ a labor. So labors are also increasing in the same proportion the way you are increasing the machine. So machines are increasing. If machine is increasing by 1 unit, then Y will change by 10.5 unit. Am I right? Now, machine is changing, raw material is changing, manpower is changing. So electricity तो ज्यादा consume होने ही वाली है. Machine चलेगी तो बिजली consume होगी. But if electricity, and consider there is a strong relationship between them, right? If electricity is increasing, then your Y will change by 9 units. Am I right? Now, what about the labor hours? Since you have increased the total number of machines, you have increased the manpower also, the total number of labor hours would also increase. Total number of labor hours is how many labors you have and how many hours they are working. Since you have increased the machine, manpower has gone up. Manpower has gone up, so labor hours would also increase. So now X5 is also gonna increase, and when X5 will increase by 1 unit, let me say Y is changing by 8.5 unit. So when X1 changes by 1 unit, X2 is changing by 1 unit. X1, X2 are changing, X3 is changing by 1 unit, X4 is changing by 1 unit, X5 is changing by 1 unit. Again, I repeat my statement. अब ध्यान से सुनना. So when you increase X1, X2 also changes, X3 is also changing, X4 is also changing, X5 is also changing. And why it is happening? Why? Because there is a relationship between your X1, X2, X3, X4 and X5. इनके बीच में एक relation है, right? There is a relationship between your machine, raw material, manpower, electricity, and total labor hours. You change one of them and another are also changing. But what is the impact when you increase the machine? Impact when you increase the machine is 3 units. But when you increase the machine, raw material, manpower, electricity, labor also are increasing. So what is the combined or the net effect on Y? Net effect on Y, can I say if I add all of them? So 4 plus 3 plus 10.7 plus 9 plus 8.5, कितना आता है आंसर? 34. So let's say the net effect is around 34. So do you notice that single unit change in X1 is leading to a very large change in your Y? 3 की बजाय कुछ ज्यादा बड़ा नंबर नहीं आता हुआ दिख रहा है. So do you think this type of thing is advisable? क्या ऐसी चीज करनी चाहिए हमें? नहीं करनी चाहिए. Why? Because do you notice there is a multiplier effect on your Y? there is a multiplier effect on your y. And so when you are increasing the x1, all the other variables are also increasing. All the other variables are also increasing. So do you notice the combined effect on your y is much more than required? And why this is happening? This is happening because there is a high correlation. There is a high correlation among your x variables. You are changing one thing and other things are also changing. There is a high correlation between among your x variables. So if you change one of them, others are also changing, and the combined effect is this much. So basically, do you notice when there is a high correlation among your x variables, a small change in x is leading to large change in y. Large change in y आता हुआ दिख रहा है? So now if there is a large change in y, it means there can be a big difference between your actual and the predicted value. There can be a big difference between your actual and the predicted value. And if there is a big difference between actual and predicted value, it means you have the large errors. And if you have the large errors, it means model is going for a toss. Model बेकार होता जा रहा है. And that is why, what was the assumption? That is why we assume minimum multicollinearity, so that the impact of change of x on y is limited. इतना समझ में आया सबको? Please draw this thing. So I will mention one statement. Try writing this. So if there is a high correlation among your x variable, थोड़ा जल्दी लिख लो. If there is a high correlation among your x variable, if there is a high correlation among your x variable, change in x1 will also result in change in another x variables. If there is change in x1 as in if you change any x variable, if there is change in x variable, if there is change in x1, it will change other x variables also. It will change other x variables also. And it will have a multiplier effect on your target variable. And it will have a multiplier effect on your target variable. It will have a multiplier effect on your target variable. So the predicted values may be far away from your actual values. And so the predicted values may be far away from your actual values. Predicted values may be far away from your actual values. And we know that if predicted values are far away from actual values, it means you are having large errors and you don't want large errors. And that is why I assume minimum multicollinearity. So I think it's already 12:30. We'll end the session. Two more assumptions are there. We will discuss it tomorrow. See guys, इस example में एक बार हम वापस आ जाते हैं. So when I had already considered the manpower, considering total labor hours was not needed. समझ में आ रहा है? अगर हमने manpower already consider कर लिया, then total labor hours should not be needed, because when you are finding the total labor hours, the formula would have been manpower into number of hours. Let's say हर एक employee 8 घंटे काम कर रहा है, then manpower into 8 हो जाता, right? So this function is automatically coming from this one. So either you use this one or you use this one. है ना? So when you have already said machines, then there is no point using electricity. Electricity तो machine पे ही depend कर रही है. Are you getting my point? So according to me, machine, this electricity and labor hours तो हटा देने चाहिए. You should not use them if you want to narrow down the problem of multicollinearity. Machine, raw material ठीक है, and manpower. Okay. Okay, guys. So I'll end the session. Everyone, please revise what we have done in theory today. And so tomorrow, when we meet, tomorrow we meet at what time? कितने बजे? 8:30. Let's meet at 8:30. And so theory part is almost done. I don't think it will go beyond half an hour or 45 minutes. And then probably just for refresher session, I will ask few candidates to present whatever theory they have done. Okay. सब लोग please follow. Okay, guys. So with this, I'll end the session. Thank you for joining and have a happy weekend.